Yes.
This is a sponsored session. Sponsor is Wildnis Manufaktur. They make mushrooms, edible. I don't know, what is it called? Gourmet mushrooms. And we're working on frappix packaging. Frappe in mix.
Yeah.
I can pilot. I just need to move these to the other desktop. Like that. Okay. Now I can share screen.
So we read this documentation yesterday.
Right. Frappil? No. What is happening here?
Oh, this is the deployment for manual testing, evaluation error.
Right, because we didn't know how to. But what's rerun with show trace? Is that like a new Nix feature? Or is that Stud? That's Stud doing this. Interesting. Okay.
Yeah.
Boy. What? Oh. Dear env. Deny. Okay. Okay. Well. A walk in the park.
Oh, yeah.
This is an excellent tutorial series by Joshua Gilman in the form of the standard book. It's ideal for people with prior Nix and Nix Flakes experience. They are written in a way that feels like a walk in the park, hence the nickname. They are also often used to dog food, some new stood functionality and documented alongside a palatable non-tourist writing style and joy. I don't know. Maybe a reference would be good enough, but is this long? It doesn't look long. Welcome to the Stood book. This book, okay. How this book is organized. This book is broken up into several chapters. Each chapter tackles a big idea from Stood while building on the work done in previous chapters. The reason I skipped this is because we read this earlier.
Yeah.
As such, the book is intended to be read from start to finish. However, each chapter is written in a way that can still be useful as a quick reference. Since Stood is a Nix framework and is intended to be used to organize code repositories, it makes sense to work through applying it to an example project in this book. We're using a very basic Rust project for which the source code can be found here. Before diving into the book, it's recommended that you clone the repository locally. Throughout the book, we'll be building out an environment that uses the above example project. The final source code for the completed example project can be found here. Assumptions. There are a few assumptions about the reader of this book. The reader is already familiar with Nix. While all code snippets will be clearly explained, none of the explanations will be focused on language constructs. The reader has experience working with Nix Flakes. The reader has general experience working within a code repository, including the common tasks and processes that occur within. Well, I thought I had Nix figured out pretty well, but then I learned of
scoped import.
Exactly. It's worth noting that you do not need to experience with the Rust language. The usage of Rust is for example purposes only. Okay. Introduction. The STUD, short for Standard Frameworks, an opinionated Nix-based framework that aims to solve the problem of complexity that often arises in large Nix-based projects. It's opinionated because it prescribes a standard flake-based structure for repositories using Nix. It eliminates the question of how Nix code should be organized and ultimately serves as a boon for productivity. In this chapter, we will briefly introduce the framework as a whole. As a reminder, this book will be starting off with an example Rust project and then slowly integrating the STUD framework into it. It's recommended you clone the repository locally and follow along with the book for the best learning experience. The Rust project is intentionally bare bones, as it's not the primary focus of the book. It's a quick overview. The project produces a single binary that takes one argument and uses it to print a string in the format of hello arg. It contains a single unit test that confirms the above logic works as expected. Why STUD aims to provide a rigid framework for organizing. We've read this before.
Yeah.
I mean, something like this before.
Yeah.
STUD organization. Repository has cells and cells have cell blocks. Cool. STUD framework is broken up into 3 organizational levels. Repository, this might seem like a given, but the repository serves as the highest level of organization within STUD. One can consider it an organism made up of one or more cells. Oh, they're not prison cells or organism cells. I mean, I'm always just projecting. Cell, the largest organizational unit. A cell typically encompasses a single component of a repository. In a monorepo, there could be 1 cell per service binary in the repository. 1 cell per service or binary, okay. An entire cell could be dedicated to the automation within a repository for smaller projects. Okay, so here you already like kind of, can cells have subcells? Cell block. A cell block is a subcomponent of a cell and serves to further subdivide a cell into smaller components. In particular, cell blocks are typed, meaning each falls within a category that defines functionality. The cell block each falls within a category that defines the functionality the cell block provides. The meaning of this will become more apparent later on. It's worth noting that cell blocks were previously referred to as organelles. And cell block types were referred to as clades. What's going on? What's a clade? It's a grouping of organisms made on the basis of their presumed evolutionary history, consisting of a common ancestor and all of its descendants. Oh. Okay. Where's Clade?
It's a biologist in computer science world.
Evolutionary biologists.
Yeah.
These have recently changed to ease adoption. While the presence of cells and cell blocks helps to define an organizational framework, at the same time, the ambiguity as to how cells should be organized provides a necessary degree of flexibility. In this book, we'll give a sample cell structure for our project, but the method proposed here is by no means the best one for every project. So you mean to tell me that you don't really tell me how to structure my Nix code? A STUD flake. The starting point of integrating STUD with our example projects is defining a flake.nix file at the root of our project. As mentioned previously, STUD is a flake-based framework, and usage of Nix flakes is not optional. Throughout this book, we'll be sharing snippets of our growing integration. These snippets will make excessive use of localized comments to explain concepts, as the proximity of these tend to make explanations much more effective. As our code base grows, repeat code will have comments stripped, and only the new additions will be commented. If you haven't already done so, clone the repository and move into the Rust subdirectory where our source files are. Create a flake.nix file as shown in the next section. Our std flake. Like any flake, we define a set of inputs that should be accessible to our project. Here we include the std library in this version of Nix packages. As per the flake schema, we define an attribute for holding the outputs of our flake. In this case, std will be responsible for managing the outputs. Grow on function can be seen as the main entry point of the std. It is responsible for growing our organisms through cells into the final product. It will produce an output schema that is specific to std and can be further explored through the std CLI TUI. The grow on function is similar to grow, but allows us to expand our... what's grow? I've never heard of grow. To expand our flake outputs to include more than just what std generates by default. It takes a variable number of attribute sets after the first one, which defines how it behaves, and will recursively... What do you mean variable number of attribute sets? It takes a variable number of attribute sets after the first one, which defines how it behaves, and will recursively update them into one final set. Without this, we would only be able to use the std CLI TUI, as by default std places outputs under the dunder std attribute, which the Nix CLI knows nothing about. Std grow on takes another set necessary for std to perform its magic. Inherit inputs. This is one of the most important arguments for the grow function. It defines the path where std will search for our cells. In this case, specifying the Nix subdirectory. A cell in this case would be defined in a subdirectory under Nix. Oh, cool. This is the second most important argument for the grow function. It informs std of the block types that exist within our cells and where they can be found. In this case, we're specifying that we have runnable block types that can be found in an apps.nix file under the cell directory. The std framework has many different block types, and they primarily dictate how the std CLI TUI will behave. For example, the runnable type will allow us to run our cell block as an executable using std /std example /apps /defaults : run. The run action is available because we've specified the runnable cell block type. In this case, we're running the default target, which is defined as the derivation in std example apps that builds our binary. Cell blocks list. First item is calling std block types runnables with the string apps. Here's what I don't get. By the way, this is, I think, what we are about to do, right?
Yeah.
As a design, I don't understand why this indexing in the grow on function. Why shouldn't the block itself declare what it provides?
Yeah, fair enough.
I don't claim to know everything. I'm just asking a question here.
Yeah.
Because, like, if you do something like this, such an indirection, right?
Mm-hmm.
Like, here is the thing, but over here is some declaration about what it is, and that it's necessary. Otherwise, it's the thing is useless.
Yes. I see no reason why it shouldn't be there in the file itself.
Yeah. Maybe this serves as some sort of a human readable index, Like here you have this, there you have that. But but a human readable index can also be the output of a command, and it'll be a better index, right?
Yeah.
Because it's not code. It's like it can be a TUI, it could be a, and you already have a TUI, right? Like that's so I'm skeptic that that's the benefit here. I just don't know what is the benefit. This second argument, as described above, allows us to expand what gets included in our flake output. In this case, we're using the built-in harvest function to harvest the derivations from our app cells block into the packages attribute of our flake output. This allows us to interact with our flake using the Nix CLI. For example, we can run nix run.hash default, which will build and run our binary packages, equals .harvest inputs.self what?
Yeah.
How is inputs? That's the first argument. Okay. And then there's a nested list for some reason. Because it's a file path or what? What
attribute
is
path. It's an attribute path. Yeah. Because by default, std puts it in dunder std inside self.
Sure. Yeah. But like, where does example come from?
The cells.
The cell is example. No, the cell is it Nix?
Yeah, it's just Nix.
There's apps inside there, right?
Yeah.
This and that. I don't know what example is then. Well, I'm kind of I'm thinking. So yeah, let's see. Let's see what the contents of, because we got a good clue, right? I don't know that we need to continue reading, but I also don't want to be lazy. Much of the structure presented above should not be surprising, as there is no major deviation from the expected flake schema. Perhaps the largest change occurs in that this structure is primarily generated by std through the grow on function. The arguments for this function are where we primarily derive the structure we discussed in the previous chapter. Of note are the following. Cells from the cells that make up our organism must be defined in a single folder within our repository. It's idiomatic to name this folder either cells or Nix. In this directory, each cell is isolated into a subdirectory with all of its cell blocks further nested under this subdirectory. Cell block, each cell consists of one or more blocks, which are defined here in list form. Recall that.
So example is a subdirectory in Nix folder. That's where example comes from. And apps is apps.nix inside example.
How'd you figure that?
From in cells from, it says that
here.
Yeah, it's a single folder within a repository. Within this directory, each cell is isolated into a subdirectory with all its cell blocks further nested under the subdirectory.
Okay. So
we could always open the source and see if that's the case.
Yeah, Nix example apps, right?
Yeah. There'll be Nix. There is no examples in Nix.
It's like follow along, right?
Yeah.
Do it yourself. I'm willing to buy that though. Each cell consists of one or more blocks which are defined in list form. Recall that cell blocks are typed, and the general format for defining them is std block types type, passing name, where type is a valid block type as defined here. Oh. And name is where stud should look for the cell block under parents. Stud name should look for the cell block under the parent cells folder.
Yeah.
But so will this apply to all cells?
Yeah, seems like it. There's no way to tell which specific cell. Or there is, and we aren't aware yet.
Look. Here's the directory structure, which is defined as a derivation in Nix stud example apps.nix.
Yeah.
That builds a binary. And here it does not refer to the cell name. It refers only to the
block.
Cell block. So you can have any number of apps in different cells, and this will pick all of them up. And that's of value for some reason. Well, then what does this refer to? Because this is stud hyphen example, not example.
Yeah. I think these are there's typos in the documentation.
With these two arguments, we can bring cohesion to our otherwise disunified Nix code. Hey, don't you call my Nix code disunified. We know where cells are defined, what block types are available, and where to find them. Determining where our runnables exist is simply a matter of examining our flake.nix and following the paths accordingly. This piece here is the value claim.
Yeah.
But you know what? Maybe. I mean, the grow on function takes a variable number of additional arguments and is what differentiates it from its sibling function grow. We will dive deeper into these additional arguments in a future chapter. Okay. It's not long. Our first cell block, the flake, by itself is not sufficient for a working example. We've told Sud there are cells have runnable blocks, yet we've neither created the cell nor defined any blocks. To resolve this, we'll create a new file, Nix example, not stud example. Now that makes more sense. Nix defined in our cells from argument. The flake.nix example, the name of our cell, apps.nix, the name of our cell block. Hopefully the stud structure is starting to become natural now. Here are the contents of our file. A common stud idiom is to place all buildables. I thought they were runnables. For a cell in a apps.nix cell block, this is not required, and you can name this cell block anything that makes sense for the project. This cell block is used to define how our example application is built. Ultimately, this means it produces a Nix derivation that, when evaluated, produces our binary. The function arguments shown here are universal, so to all cell blocks, we are provided with the inputs from our flake and a cell attribute which refers to the parent cell of this block falls under. Note that the inputs are desystematized and are not in the same format as the inputs attribute in the flake. Hold on just a moment. But inputs are not systemized. So how can they be desystematized? Is that like it's not their okay. It's similar to per system, to flake parts per system, where inputs here will have like packages at a system.
Yeah. They have inputs prime in per system. Yeah.
Okay. And not the same file. This is a key benefit afforded by stud. Okay. Good thing they're not showing the import, scoped import example here. Let the inputs attribute allows us to access all of our flake inputs. So we have packages instead. This is a common idiom for combining lib with built-ins. No, it's not. I've never seen this before.
It looks like a bad idea.
Also, it's L here, which I've also never seen before. We can think of this attribute set as what would normally be contained under outputs.packages in our flake.nix. In this case, we're defining a default package which contains a derivation for building our binary. Default is the only attribute here with inputs expected. Count the anti-patterns.
Yeah.
Rust platform build Rust package, pname, version. Stud includes some useful helper functions, one of which is incl, which handles filtering out unwanted files from our package source. Benefit here is it reduces unnecessary builds by limiting the input files of our derivation to only include those that are needed to build it. Source stud incl input self. It's like source filtering.
Yeah.
Cargo lock. Okay. Lock file input self meta description. Cool. Standardized arguments. One of the major benefits of this can be seen in the first few lines of Nix code. As is fairly typical with Nix, the file serves as one large function. However, the significance of the argument structure can be easily overlooked. This structure can be viewed as the standardized form of all cell blocks. From these two arguments, it's possible to derive all values required to perform our logic. Again, this cannot be overstated. We define the arguments the same way each time and are guaranteed access to all of the tools and data required to perform our logic. Historically, passing around information in Nix has been a major pain point. The further down the rabbit hole we go, the more difficult it is to bring the required information to perform the tasks at the bottom. We can visualize the benefits that brings here with a small table. Type, packages, functions, other, inputs, cell, that's the type, inputs, cell, and inputs.cells, packages, inputs, Nix packages, cell runnables, inputs.cells.star.runnable. What the heck is inputs.cells, man? Did we see this? What is this?
No, we haven't. Is
that an injected input?
Yeah, I believe.
Fake input?
I mean, not really an input, but argument to output. Because that's what we pass on to grow on, right? All the arguments to outputs as inputs.
All the arguments. You did?
Yeah. So if you look at grow on function, you inherit inputs, and that inputs is all the arguments, all the arguments to outputs.
Well, those are the inputs. Those are the flake inputs. But it don't include cells.
Yeah, like there's also self in that, right? Which
sure.
Cells is probably injected in there somehow. I don't know how.
Yeah. lib cells function. Okay. With this structure, we can access all of our flake inputs, including X packages, all local cell blocks, and even cell blocks from sibling cells. No matter how large our project grows, the same pattern for traversing it will be maintained. Standardized package definitions. The remainder of the file should look familiar to those attuned to Nix. It's nothing more than an attribute set where the name is a package name and the value is a derivation. This section, of course, benefits from our standardized arguments because we can easily access everything we need to build a proper derivation for our Rust binary. In addition to the above, it also ships with some useful helper functions for performing standard Nix operations. In our example, we utilize std include to filter out the source files for our project. Since derivations are hashed based on their inputs, limiting inputs is the best practice to maximize cache usage. Okay. Growing. It's important to take a small detour at this point and explore the std grow on functions in detail. In particular, it helps to inspect the output of our flake to better understand what it is that these grow functions are generating. If we refer back to our flake, we'll recall that we use the grow on function for generating the flake output. Let's assume for a second that we instead chose to use the std grow function. If we were to inspect our flake output at this point, we would see something similar to this. Okay. This looks strange at first. What is understood? This attribute is generated by the grow functions and is referred to as the registry. It houses a plethora of information about a standardized environment, and you can inspect what's under here by running nix eval json. Yep. Or use the REPL. The output is large, so it will be omitted here. Can you really do that, though? You can't eval json that. There's derivations in there, I think. The output is large, so it will be omitted here, but essentially it describes our entire environment, including what cells we have, the blocks and their types of those cells, what actions we can run on the blocks, etc. The benefit here is that it provides a layer by which external tools can utilize the information gathered about our environment. What about all the unknowns? There is data here, but it's important to understand that it doesn't conform to the expected flake output schema. So Nix-flake show just marks it as unknown. Again, we can see the structure by growing into the Nix REPL environment. So node the flake. This is the one system. Std hyphen example. I thought it was going to be example. Apps defaults. It's a derivation. In other words, we could run our binary using that. However, this isn't very intuitive, and this is why the grow on function becomes helpful. It allows us to add a compatibility layer by transforming the above structure into something that the Nix CLI can more easily understand. In our case, if we run the same nix-flake show command with the grow on function, see. Okay, now it's other packages. But there's still these systems here at the root. This now allows us to run our binary using x1.hash_default_world. The std TUI. There's one final thing we have gained from our work so far. The std framework ships with a binary that adds a terminal user interface to our project. The quickest way to experiment with it is to enter an Nix shell with the package installed. With the std binary now available, we can open the TUI with std, for example, repository we're met with. How do I do this? target actions run. Okay. What we're seeing here is a graphical view of our project. In this case, we have a single binary located at example apps default, which can be run. How does std know this? We recall that we informed std we have a runnables located in appsnix. When std analyzes our repository, it automatically found the runnables of our example Rust project, showing us what we can do with it. This may seem trivial, but that's only because our repository is small. The usefulness of the TUI grows in proportion to the size of our project. As we add more and more pieces to it, the TUI begins to become an entry point for contributors to explore our repository. In addition to the TUI, the std binary has a CLI counterpart that will show the structure of the repository, std list. If we wanted to run our binary, we'd use std example apps default. Okay. No? Review. Before we continue into more advanced subjects, let's stop for a moment and review. What have we gained here? First of all, we have standardized where our binary builds are defined for our repository. If you want to add additional builds, i.e. the debug binary, we know exactly where to put it. As a bonus, we don't even need to worry about the system fiasco that flakes are often criticized for. Secondly, we have standardized what most of our Nix code looks like. The input cell format is deceptively powerful. One of the most significant sources of complexity in large Nix code bases stems from the question, how do I access everything? In our case, inputs can be accessed via inputs. Anything within our local cell can be accessed via cell. Other cells can be accessed via inputs.cells, meaning that as long as we adhere to the organizational principles being applied with std, we don't have to worry about figuring out where to put things and how to access them. Managing dev shells, managing development shells, dev shells. In the remaining chapters of this book, we're going to begin improving the foundation we laid in the previous chapter. We already gained a lot by integrating std into our example Rust project, but there remains significant room for improvement. So far, we've seen that std has a lot to offer in terms of bringing organization to our Nix infused repositories. In addition to organization, std also brings with it many quality of life improvements. We're going to investigate the first one in this chapter, development shells. Works on my machine. The risk of, okay. Okay. Let's skip this.
Yeah.
Adding the dev shell block.
It's just
New
that
block.
1, 2 lines.
The dev shell type will allow us to have development shells available and managed by num-type dev shell. The function type is a generic dev shells, functions. Block type that allows us to define some common Nix code that can be used in other cells. In this case, we're defining a toolchain cell block that will contain derivations for the Rust toolchain. And then what? Packages to harvest input self example apps. We want to export a development shell so that the following works as expected Nix develop, or we can put the following in a .env. Yes. Why is all of this like explicit? If this is if std is for flakes, why don't you just do the right thing that has to do with flakes by default? Why do I have to explicitly say this stuff?
But because the cells exist, you don't know which cell to pick it up from automatically. But I guess.
I mean, if you just make this behavior built into here to the types.
Oh, like that, yeah. Yeah.
I don't know. I'm just criticizing it. The first thing to notice is
I mean, they do have arguments to those cell blocks saying whether it should run in CI or not. So similarly, they could have whether it should be auto-wired into the flake outputs or not.
Yeah.
Yeah.
Sure. But even if you do that, if you want that, then let the block let the cell block declare these things.
Yeah.
And make same defaults.
Yes.
First thing to notice is we added a new input for the Rust overlay flake. Oh, did we? Okay. This flake provides, okay. We've added 2 new cell blocks above, one of the dev shells type and the functions. Okay. I think I get it. Defining our dev shell. Okay. So we have a Nix example dev shells.nix.
Mm-hmm.
That's why this is here. And defining our dev shell. Input cell, inherit inputs, Nix packages stood. L. Here we map an attribute. Okay. L map adders. Don't care about the name. Stood lib make shell. Okay. Stood lib make shell. 1 default shell. Yeah. So we didn't really need to use map adders.
Yeah.
This is our only development shell, so we name it default. It's a function for some reason. Maybe because it can take PKGs or something. Cell toolchain Rust stable latest default. Imports. Imports for what? Modules here we can import. Oh, this is a module.
Yeah.
So next package is module system module. Okay. There appears to be a lot going on here, but it's fairly straightforward to follow. Okay. Whatever. I don't want to read. Do you want to read this?
No.
Finding all toolchain. Integrating direnv. Okay, we know how to use direnv. Review. Took advantage of the integration dev shell, create a nice message of the day, custom command. This cargo, I didn't see that. We provided contributors with the latest version of the Rust toolchain. Wrap things and managing configurations. What is a Nixago? Do you know?
No.
Oh, it's all this formatting and git hook stuff. Ready to dynamically generate configuration files in your flake-based setup. Nixago is a flake library for generating configuration files using expressions as the data source. I get it. This thing is dead. Okay. So now we know what generated those config files.
Yeah.
Managing configuration. Okay. I think we know enough. We just need to see the reference, right?
Summary.
These things. Okay. I'll be back soon.
Yeah.
Okay.
Yeah.
All right.
Yeah.
Rotate.
Yes. Sharing screen. Shared.
What is Arion?
Yeah, it's Arian, Compose, Hercules, CI. Stuff.
Well, what does this include dot nix? How does that work? Does it nix that evaluates into Markdown?
Maybe it's a MD book thing.
Sure, it's like a custom custom directive, it's like a custom include directive, but so I mean whatever. Like there's something called Arion. But what is Arion? Because we have it in the project.
Yeah, we do.
So can you go to that next file?
Oh, okay.
It's by Hercules CI.
Yeah.
Oh, weren't you saying that it's something about micro VMs?
No, I said it's like Docker Compose, but
Okay.
yeah. So you can start a bunch of containers at the same time and define what each one does and things
Okay,
like that.
fine.
Yeah. Yeah.
So apparently we have something with containers in the project in frappix.
Yeah.
What other block types?
Uh-huh. Runnables, Xrun, installables,
Okay.
EKGs, dev shells, Xago, containers, Terra, data, functions, anything, kubectl, files, micro VMs, Namaka, XOSS, I don't know what this is, Namaka. Nomad, yeah, I know what Nomad is. NV fetcher. Okay, that is all.
Okay. So I think now that we know that Arion has to do with composition of containers, maybe it can be part of our. Maybe there is some manual testing facility locally.
We can look at the Arion tests.
Perhaps fire up the stud TUI and
Okay.
see what.
Seem to have modified changes here. But, okay. Should I start the mob timer?
No.
No. Okay. Yeah. Stood. Oh. Oh yeah. Right. I'll just git revert the changes that I made here. What is this? Oh, the trace seek built-in break. I'll just revert this.
Git restore.
Oh, restore. Restore dot. Yeah. And if you're not on main, you're on manual testing.
Yes, but I don't know what we have there in manual testing. What do we have?
Yeah. Nothing really. But okay. Okay. Stood. and
Search.
filter.
Filter.
Beyond. Yeah. And we have this. Pass any command to Arion. Config. Oh no. Yeah.
Try up.
Up. I've used Arion Compose before.
Lovely.
So it's broken.
Yep. Okay. So what is it trying to do? Now it's broke. We cannot just try it.
Yeah.
We need to read it.
Let's see. Stdlib, there's some dev. Don't know what this is. There's inputs.cells. Source, OCI images. Not sure what this is either. Environment. We have Redis, database, I'm assuming MySQL, socket IO port. Image, there's a frappix base somewhere. Okay. There's a make Arion function. That takes the name of the project and the volumes for Docker Compose. And defines services. We have the database.service in services. And the base images MariaDB 10.6. Restart condition is unless stopped. There's no health check is commented. This looks like the extra args to MariaDB.
This image,
Uh-huh.
it's from the registry, isn't it?
Yeah, that it comes from Docker Hub or some place like that.
Boy. Okay. Okay. So whatever. Redis, front
Redis
end,
queue,
back end.
backend. Oh, use host store scheduler. Worker short, worker long.
Why do the commands not have commands? Why do they have only arguments? What is inherit image? What is that shared image?
That's the frappix space. We can look at the frappix space.
It doesn't matter. So this is supposed to, when upped, it's supposed to give us something for manual testing, right?
Yeah.
So we have two distinct ways to. It's like it's not even based on, not entirely based on NixOS, right? Like the OCI, the frappix based OCI image probably built using NixOS, but the rest are not.
Yeah.
Why? Like, is one way of doing things not complex enough? Do we need to come up with a second way of doing things? What's this?
So this is the frappix base. This is the frappix base. It's different. And that comes from somewhere else. OCI.
Uh-huh.
Frappix. OCI frappix. Yeah. OCI.frappix.
Well.
Yeah.
If this doesn't work, this will continue to bit rot.
Mm-hmm. Yeah.
But also, if even even if it does work, it's not locked, is it?
Yeah, it's not. Wait. Yeah, it is. It's not.
Is there some registry involved here that is already locked? Is there a lock file for OCI? For Docker, for whatever the images come from?
No, there isn't.
It's just that?
Yeah.
Oh boy.
From what I remember, you have to mention the SHA-256 hash for locking.
Yeah, but maybe there's an additional log file Arion supports, and
I don't remember.
Well, not Arion, maybe not Arion itself. Maybe it's this Arion tooling for Stud, or whatever Stud uses.
Yeah.
Like if you search for one of these images, right, like MariaDB, where does it show up in any file that looks like it's a log file?
No.
Okay. Well, then it's hard to make sure something working when you're not, when it's just the thing's a moving target anyway, right?
Yeah.
Okay. And this whole, so the of the images, of the OCI images involved in that whole thing, which are built by this project, and which are built by this project, because we need to know, because they share code with. If we modify code, we need to understand it affects also these OCI images.
Yeah, it's only frappix base from what I see.
And where does that come from? It comes from NixOS?
It's source OCI. OCI main.nix. Yeah, this is where it comes from.
What are we looking at here? What is the option?
Oh, the option is here.
So it's a set of options. Name, debug package. Package is just frappe. Apps. It's a list of apps. Right?
Yeah. Oh,
Bench directory. Implementation. Apps. Pre-processing. Combined assets. PNV. Packages. Bench directory environment. Python path. Fine. Output attributes. One of these output attributes should be
yeah.
I don't know what that is. Ops. Where does ops come from? Some stud thing?
Yeah, it's an argument to this file.
Why does this look like... Okay. Is this a cell block? Yes. Okay. Make operable.
Wait, is it a cell block? Main? No, it's not a cell block.
It's not a cell block. It's imported from some other cell block.
Yeah, yeah.
Then what module is this? What class?
OCI main. OCI, it's imported in OCI.next and is OCI in cell block.
Show where it's imported.
Yeah. Oh yeah, OCI is a cell block. Okay. It's imported in this OCI.next here.
Imported into what?
Some frappix top level attribute. Main
What is
frappix.
that? And why is it oh, it's a there's look it's a meta description and then functor.
Yeah.
Functor. It's a functor for it to be a next packages module system module.
No, but that's test trig.
So do you think that these are NextOS modules?
Mm-hmm. OCI test trig. This is the one.
Is OCI an NextOS option or declared here somewhere?
It is declared here. I don't know if OCI is an XOS option. We can check that. Is that XOS? No, doesn't look like.
Okay. Well, then where's the NixOS? Where's NixOS itself?
There
Because
is
I'm not.
source NixOS under this. So OCI and NixOS are separated from what it looks like.
It's not an NixOS module, is it?
Yeah.
Is there a lib.eval modules anywhere?
Eval modules. Yeah, here. OCI images. Up next.
And it gets its PKGs from the cell block.
Yeah.
Evald. Evald is that configuration
Mhm.
of frappix and tester. Okay. And somewhere in frappix or in testrig, OCI frappix, OCI testrig, is the frappix NixOS module involved? I think it must be.
I don't know. I don't see any NixOS modules being imported in any of these. So OCI frappix comes from here. OCI test rig is here. And
Yep.
OCI frappix only imports OCI main Nix. And
Okay, follow that.
OCI main Nix has no reference of NixOS anywhere.
What about testrig?
Same, I think. Let me confirm. OCI test rig. Yeah, this is also this no NixOS modules here. So they are decoupled.
Okay, so this OCI container thingy
Mhm.
is doesn't need a systemd. It's like
Yeah.
it's similar to nspawn. It's an executable. It needs an executable, right?
Yeah. Yeah. They're app containers as opposed to system containers.
Okay. So the NixOS module should not affect them, but on the other hand, they're already broken. We cannot test them.
Yeah.
Unless we fix them. And anything we do but like, do they even have tests? It's like we tried upping them manually, right? Okay, that broke. It didn't seem to break in anything that has to do specifically with the OCI, right? It was more like a general packaging problem.
Yeah.
But do they have tests that we can try to fix? Or delete the darn things? I mean, maybe OCI is like the more reasonable way to go here in some regard. I don't know yet. It's difficult to tell.
Yeah. This is the only place where they mention running bench at all. But there's no bench run tests or anything. It's just running they're just running the workers and schedulers and web server. So they expect you to run the test manually, or this is probably just meant for deployment. And
Who the heck knows?
Yeah.
Maybe it's like I don't know. Maybe it's just there are no tests, and we should accept that. And like for me, if there are no tests, then it's like it is okay to bit rot, basically. I mean, maybe that's why it bit rots already.
Yeah.
If it ain't broken, don't fix it. If it ain't
Yeah.
fixed, don't fix it either.
Okay. So we go back to the VM.
Yes, but can we have a discussion on like the building blocks that we have that are reproducible, that are NICs,
Mhm.
for making multi-service services, right? Multi-process services
Mhm.
are all in the context of NixOS, right? They're all just NixOS. Sure, NixOS itself can be packaged as some kind of a container or other, but it's all NixOS things, right?
Yeah.
And our plan for parallelizing the automatic tests is to use just like we're currently using VMs and spawn containers, and each one of these has multiple services.
Mhm.
Each one is like a so in nspawn containers is what's the interface for nspawn containers? It's like it's not just an executable, right? It's because it can do everything that an XOS test can do, right? So it's like an entire kind of a systemd namespace.
Mhm.
There's no kernel, but there is systemd unit. There are systemd units involved.
Yeah.
So arguably, we could use nspawn containers to do the same, to do manual testing as well, right?
Mhm. Yes.
As assuming we can get, assuming there's no permissions issues, right? But I mean, you know, nspawn container NixOS tests
Mhm.
require a certain version of Nix, and
There's some experimental features.
yes, but they don't require special permissions after we have those experimental features in the. It's the Nix daemon that has the special permissions.
Yeah. Yeah. But shouldn't we like have a way to doing manual testing first before going to nspawn?
Yes, I was just
Yeah.
contemplating whether manual tests can also be with nspawn containers.
Oh yeah. Yeah. I think it can.
But we're I think we should get into that. Do you think we should try that first, or we should aim lower? And it's not that I
mean,
did a
even
QEMU. The QEMU VM is easy, it's trivial, because you make an NixOS configuration and you just have instead of a top level, you use the VM, right?
yeah.
So because that's trivial, do you think we should go for that and then later look at whether we can convert that to nspawn?
Yeah. Yes. I think we should fix the manual testing in the VMs and then to convert that to nspawn.
Well, by fix you mean create.
I mean, yeah, create. Yeah.
Okay. I think the way this is going to work is we're probably going to start, and then we're probably going to notice, this thing needs to be something needs to be refactored, something needs to be fixed. But yeah, let's start.
Okay.
Now that we supposedly know how to use stud.
Yeah.
Also, we can rotate.
Yeah.
Shared. Okay, I am in manual testing. Where's 7? 7 is here. Nope. Here and allow. This is broken. Why? Because manual
Deployment.
testing is broken. Okay, so I'm going to like it's mob, I don't know, mob next to this, if it allows, and switch mat main, and then reload. Sorry, mob T6 and git switch hyphen, and we have a. We probably need to take a look at the flag dot next to this point to see what, right? Like we're looking for runnables, right? So like jobs, right? Do we expect? Now I'm confused. Are you confused? Because I was looking for files called jobs to be inside. Oh, but it checks out, right?
Yeah.
This is a cell.
Yeah.
And it has runnables. Now, if I add inside deployment for manual testing, right? And we like accept that this file is not called default, but it's called jobs. Then maybe we'll get what we want. But this says CI false. Why? Also, it says for downstream use, which I don't understand. So what are the jobs, the existing jobs? New site. It is for downstream. Okay, so that's not the cell block that we want. We want a new runnables cell block.
Yeah. Why is it a runnable again?
Because we're going to run a VM. Right?
Yeah. But it's also a NixOS test. The VMs are NixOS test.
No relation. We're going to make a NixOS configuration, and we're going to use its config system build VM as a runnable, or maybe wrap it in a script that runs it, and
inside that VM we parallelize.
No, we're talking about manual testing, right?
Yeah.
There's no parallelization. It's just a VM, an NixOS VM that starts, and it has a deployment, like a blank deployment. And there's like a HTTP port and port forwarding to let you get in there with a browser and start digging into whatever you want. That's
okay. That's yeah, okay. Yeah. Yeah, then we can make runnables VMs. VM something.
Okay. There are categories here. I don't know whether I don't know. Maybe okay. So maybe like this. Let me see. Runnables. We can call it. It's really funny. So now I'm supposed to use right. I'm supposed to use stood, and I'm supposed to understand it. But like, why do these even have names, right?
Mm-hmm.
So jobs is supposed to be a concept that could, or like like an instance of a runnable, or like a kind of runnable that might exist in more than one cell, right?
Yeah.
So let's examine that. Do templates exist in more than one cell?
No.
No. Only in examples. Do overlays exist in more than one cell?
Maybe not.
Hold on. I'm working on it. Oh, it's not that kind of expression. I'm supposed to find an overlays.nix, right? I'm not finding an overlays.nix. Is that clear to you? What's going on? Maybe
Yeah.
it's because it's the default.nix.
Yeah. If it's mentioned in the documentation that if a cell block doesn't have its file name, then it can be a directory with the default.nix.
Okay. So there's one. Okay. pkgs.nix, also one, apparently. I mean, this is
Two.
part of a template. This is a template. It's
Oh,
part
yeah.
of a template. I mean, it looks like a cell, but it's a template, right?
Mm-hmm.
It is a cell in a template. It's not used locally, right?
Mm-hmm.
Sources.nix, just one of these.
Mm-hmm.
Nixos.nix, one of those. Shell.nix,
Two of those.
one.
Oh no, that's
Huh?
shells. Yeah.
Yeah.
That was shells.
Nixos tests, just one. You can see my point, right? Like,
Mm-hmm.
there's an entire core stood feature here in not a small project. It's a tiny to small project, right?
Yeah.
Sorry, like not a tiny project, maybe a small project. I don't know what to call this, but it's like entirely unused. OCI.nix, right? Entirely unused. You know why? Because doesn't seem of great value. And this is by the author. This is the author using his own thing.
Yeah.
Sorry. Many people are like, avoid criticism. This gets me into a lot of trouble. I mean,
Mm-hmm.
it would get me a lot of trouble if I was behaving this way and allowing myself to be so critical in area where I live geographically, which is Thailand, which is a very, how do you say, conflict avoiding
Yeah.
society. But yeah, we're doing engineering here, so it's not
Mm-hmm.
config.nix. Oh,
Oh.
config.nix.
Yeah.
Beautiful. So config.nix is an anything, which
Mm-hmm.
maybe defeats the purpose, because anything doesn't really do anything, right? Doesn't really do anything specific, right?
Mm-hmm.
So I would say this is not a saving grace. It's literally, right? Literally unused feature. The fact that these are named. you might as well just say, you know what? Dev shells are just always devshells.nix, right? And containers are also always containers.nix, and runnables are always runnables.nix. And then you'd be producing more value.
Yeah.
You can't be trying to solve the problem of a lack of structure and then not enforce structure.
Right.
Okay. So I'll get off my podium and my and the helm.
Yeah. Sharing. Shed. Mob start. All right. So we just change that default .next to jobs.next or something in our deployment for manual testing. Or create a new runnable.
Did I not? What did I do?
Nothing.
I think I know why I did nothing. That's because sorry, my saving. Let me mob next again. There, try mob starting.
Oh yeah, it's empty.
Okay, runnables. If we follow the actual usage pattern, then we just call this after the name of the file that we like. It's the only thing in the cell, right?
Yeah.
So I'm like, heck, why not call this runnables? Like, why is containers called OCI images? Why is Arion called Arion Compose? Why is DevShells called shells, right?
Yeah.
Why? So why is runnables not called runnables? We already have a runnables called jobs, but that has a CI false. So that actually makes a little bit of sense that you have a configurable runnables that has a name, right? So runnables with CI false is jobs. Okay. So runnables with maybe we can just call this runnables, right? Because it doesn't matter. It is just runnables, right? I don't know what else to call this. And then we just call it runnables inside the cell. Another reason this is silly is because, like, who said that I want the runnables to be in one file and something else to be in a different file? What if I feel like the best structure here is to put a runnable and some other thing in the same file? You know, I'm not doing this for the sake of just criticizing. I don't enjoy it. I just trying to.
No, I mean, makes sense.
Get good at this stuff.
Yeah.
All right. So a runnable, it will fail because I don't know what is in there. It's like null, literally.
Yeah,
right?
it's null. Yeah.
What happens when you try to run null?
Build it, run it. Cannot coerce null to a string.
Fine. Cool. Very good. Let's go there. Okay. Give us inputs and cell. Or rely on, follow the pattern, the existing pattern. Rely on the existence of inputs. So don't do that. Right?
Yeah.
We don't even know what to inherit yet. And where do we get PKGs from?
That's from inputs.
Cell?
Mm-hmm. XOS tests. This is where it gets cells. Yeah, cells.
From cells source. That's because of overlays, right?
I think yes. Yeah.
Okay. Okay. And there's no module system involved here. This is just attributes, right?
Yeah.
In these files,
Mm-hmm.
which is unfortunate. And another way in which like flake parts is nicer. And probably also devenv.
Mm-hmm.
It's module system.
Yeah.
Not that module system is the nicest thing ever, but so let's make an XOS configuration.
Okay. We can just it'll be the same as this, right?
How about we instead make a new shell script?
Mm-hmm.
And see whether we can run it. It's a good progress.
Okay. Okay. I'll just get this PKGs in. And call this something. VMs is fine.
Well, it shouldn't be plural, should it?
Yeah, just test VM, run test VM. Yeah.
Well, run is an action.
Yeah.
And this is a runnable. So the runnable is a
test VM.
Is a script. It's not only the VM. It's some
VM
sort of
script.
It's a script. VM script. Run VM. Just call it script. And this will be a pkgs dot.
Write new script bin something.
Write new bin.
New bin. What does it take?
Is it just a? It's just a name. Is it like name, adder set, and text?
Oh, it's writers.new bin.
Right. I'm sorry. Writers. Okay. It's polymorphic. It's polymorphic. It's like name and text or name and
attribute.
That's right.
I'll just paste
we are going to use attributes as well.
Yeah. Oh, okay. I'll rotate then.
Mm-hmm.
Up next.
Sharing. Shared. Okay. What writers? Oops.
What?
It's my formatter. I'm using something that has a bug. It's already been fixed. Waiting for it to fix the Regionix packages. Basically, I just need to.
And is the line number 6 correct? It's closes early.
Yeah. Well, don't know what I'm putting inside there.
Okay.
Let's see that we can run it.
Mm-hmm.
Does it have completion? It's too much to ask. Let's do this and Can I grab this? No, wrong key, wrong key. Okay, we're getting there. Do you think it's this?
Run.
Oh, good. Looks like it's working.
Yeah.
Print. Cool. Okay. So we want to launch a VM, right?
Mhm.
So let's see, like, my VM. Let's see. I want to do an X build. Oh, I can do NHOS build. Take a while. I actually don't want to build that. I want to build the VM. Build VM, right? That's what we want to do. I wonder why it's warning me that it's guessing. Oh, because it's a VM image. That's why it's warning me. Wow, that's it's a big one, isn't it?
Yeah.
Okay. So inside here, we have a result bin and one executable. So does that mean that it also has a meta main program?
Mhm.
Probably, right? So does that mean that we can just do, and it's run something VM, right?
Yeah.
Run test or manual test VM. And here in native build inputs, right?
Mhm.
Sorry, wrong. That's right. We'll have our test v. Well, we'll have our configuration dot config dot system dot build dot just a VM, right? Wrong. Yeah, that's not the key. It's see, this is why I need the waiting for the homing
Home
key.
key. Home key. Yeah.
Configuration is something like lib NixOS
System.
modules.
Yeah. And also system.
I think system is obsolete. Why shift? It's Nix pack. I think basically we're going to do Nix packages equals. Sorry. It inherits Nix packages.
Mhm.
Wait, my screen turned off. Mob, because we want to keep the PKG's instance, not allow it to instantiate its own.
Yeah. Shared screen. Mob start.
So inside Nix packages,
It'll be import.
terminate the attribute and inherit PKGs. Yes. That's how you give NixOS an explicit PKGs, and thereby it does not instantiate its own.
Mhm.
So that's one thing we do in this NixOS. Another thing is we import the frappix NixOS module.
Yeah. These. NixOS.
Somehow it's under NixOS.
Yeah.
I don't know
The
how that
Nix.
happens.
Yeah.
Oh,
It should have been NixOS modules, but yeah.
you're not in the right file.
You just need these two, right?
Not the test rig though.
Mhm.
Just that. Well, yeah, we have a modules here, so we don't need an imports. Yeah, so you can stick it in the list of modules.
Yeah. We can try running it, can't we?
Yeah,
What else do we
sure.
need?
I mean,
Yeah.
we need to enable Frappe, right? Services Frappe enable true.
Mhm.
That's a minimum we need to do there.
Is it?
I mean, we also need to give it state version and.
I don't see them enabling Frappe here in this anywhere. In NixOS test.nix.
It's probably in the test rig.
Oh, maybe in test.nix. No, that's not test.
In the test rig.
In the test rig. Oh. Oh yeah, right. Services. Frappe, yeah. Oh yeah, this bit.
Right. We need like a enable true and a project,
Mhm.
and then an admin password. I don't know. We need some of this stuff, right?
Yeah. So now I'll just enable it.
Sure.
True. Yeah. And we can try running it.
I think we need state version.
Mhm.
System.state version 2605. We probably need networking host name.
Do we?
I don't know. Let's try. Let's try running it. Do we have
Yeah.
an evaluation error if we don't?
Let me just copy that deployment from, oh, no. Yeah, we do. Undefined lib. Do not get lib from here. Cells
See where they got lib from.
Nixos test. They got it from this. They import Nix packages and again.
Okay.
Oh, and there is this. What is this? Oh, this is the actual lib. Yeah.
So you know what? If NixOS lib is imported explicitly, we should follow the pattern and not use lib NixOS system.
Okay. Oh, yeah. Okay. This and this needs Nix packages. What is that? Yeah. The Nix packages comes from here. Runables. Yes. And we need NixOS lib. Yeah. NixOS lib. NixOS system.
It's not quite that. See how it's used over that
Oh,
file.
right. Yeah. It's just, oh,
Maybe it's not even that. But there's a way to, and we should probably do that. There's a way to avoid using libnixOS system because libnixOS system is a flake only thing.
mm-hmm.
I think we should avoid it.
Okay.
We should do the other thing. The other thing is, I think if you explore the Nix packages source code, you can find out easily what it is. It lives under NixOS. So what's in NixOS default? It's a function that takes configuration and system, and uses NixOS lib eval config. See that?
Yeah.
So it's a little wrapper, but I think we should use lib eval config instead.
Yep.
Because this wrapper is like too impure for me. I don't know.
Mm-hmm.
Okay. The only thing that really bothers me about this wrapper is that it takes system.
Yeah.
And I don't know. Do you think that's a problem?
Not if this exposer system is good.
Let's see. NixOS. NixOS. And like NixOS. Oh, we have NixOS twice. Eval NixOS. Eval. And it takes configuration system. It's interesting. Inherit packages and platform. Not this. That system configuration is basically this, right? Oops, bad key. And then this becomes imports. Can we format this? Thanks. What do we have here? Tree.
Alejandro.
Ah, Alejandro's good. Hey, Alejandro. Okay, this looks reasonable. This will probably be packed. Stood. Run. Unexpected argument native build inputs. This apparently does not take native build inputs.
Yeah, there is make wrap something where you can set the path. If you look at the Noogle documentation.
How do I do this? No. This way.
Yeah, make wrapper arcs.
That's not. That's this. Really?
Or we could check the next package source for the arguments of this function.
Right. No. Right. No. Make scriptwriter. Interpreter. Check. Make wrapper args. So if lib is either args or script, and lib, not lib is the revision args or script, then we call it with make scriptwriter first argument is the just passed in, and in this case, interpreter is overridden. Okay. But the only thing that this accepts is these three. Interpreter, check, and make wrapper args. So you're right. That's like literally the only way.
Yeah.
But they kind of sucks. It's not a nice API. Make wrapper args. So
you could, or you could just inline the script, right? Can't you? Like string interpolate.
I support that. Do you support that? Where's my lib? Whoops. Okay, but this now becomes that. And now we don't need this.
Mm-hmm.
Okay, whatever it is.
Oh, yeah.
Project.
Yeah.
Okay, I
Sharing.
think we have enough rotations.
Yeah.
Let's have a chat.
Okay.
I think we know exactly where to continue next time, right?
Yes.
Trying to do the minimal
Mhm.
manual test. A command for it. We figured out the stood part of that.
Mhm.
It seems. Now we just need it to run, and then we need to get the port forwarding to be like not hard coded, but like 0 automatic, and maybe there's some memory configuration stuff involved. Maybe there's also like some sort of addition to that we could make where it's the state file, right? Like the storage, the volume, right?
Mm-hmm.
The QCOW file system or partition, whatever it is, right?
Yeah.
Is persisted.
Mm-hmm.
And that's good manual testing, because especially if you can persist it, and then you I have this QCOW file here, and then you can just keep these QCOW files, and that's your like state for one of these, and then you can just keep it around and pass it to someone else and say, hey, at this revision, I don't know, I'm just thinking out loud, but it seems useful for debugging to be able to keep those around.
Yeah.
Okay, cool.
Yeah.
All right. Session sponsored by Wildnis Manufaktur. We have another one later. So, stop the recording.